Okay, so this is your first set of examples. So this is you trying to find the relative atomic mass, which is the average atomic mass that's on your periodic table down here at the bottom. Okay, relative atomic mass. When you're given an isotope and its percent abundance, in other words, how many of that element there is on the planet. So calculate the relative calculate the relative atomic mass of bromine. Bromine 79 is how you'd read that, has 51% abundance. So that means of all the bromine atoms on the planet, 51% of them have a mass of 79. And bromine 81 has 49% abundance. So our formula for this is relative atomic mass equals mass times percent, and then we're going to add on there another mass times percent, and we're doing that because we're doing two of these guys. Okay, so I like to abbreviate relative atomic mass with RAM. I'm going to take the mass of the first one, so I'm going to circle these two guys that go together, and I'm going to circle these two guys that go together. Whoever is circled is going to go together. So bromine 79, the mass number is 79. And I'm going to take that times its percent. So it's 51%, but I'm going to change that to a decimal. So in other words, divide by 100. So 0.51. Okay. Then I'm going to add to that this other set. So the mass of bromine 81 is 81 times, instead of 49%, I'm going to do 0.49. It's a decimal point. And I've got two sets of parentheses. So you can do this a couple of different ways. You can go ahead and do 79 times 0.51, which comes out to be 40.29. And 81 times 0.49, and that comes out to be 36.69. And then you can add those together. Okay, this is why I like real calculators, okay, because they have functioning parentheses. So what I'm going to do is use those parentheses to my advantage. I'm going to open a set of parentheses, so using that parentheses key, and I'm going to do 79 times 0.51, and then I'm going to close that parentheses. I'm going to add to it the other set of parentheses, 81 times 0.49, and close that set of parentheses. Bam, it does all of my math for me, so I don't have to write down the answers in between and retype everything in. In fact, the less you're typing in your calculator, the better, because the more numbers we type, the more likely we are to make a mistake. Now, we don't do sig digs for this because we're going to get ours to match our periodic table. So I'm going to write down 79.98. Our periodic tables have 2 decimal points for all of our numbers, so all of our answers are going to have 2 decimal points. So 79.98 is going to be my answer here. No label, which pains me to no end. I can't even tell you. And that is our relative atomic mass. I'm going to box it up like the present that it is. Okay, now, how do I know if I'm right, Mrs. Miner? Maybe I didn't put it in my calculator right. Maybe I didn't put the numbers together. I don't know. What I'm going to do is go find bromine on my periodic table. It happens to be 79.90, which is really, really, really close to 79.98. If they're super duper close like that, you're right, because yours aren't going to match exactly on your periodic table, because it'd be too easy to cheat. But if I were to get like 7,998, the most common mistake you made is you'd put a 51 here instead of a 0.51, or a 49 here instead of a 0.49. Okay? Or maybe you turned one of them into a decimal and the other one you didn't. All right. The element copper has 2 isotopes. Copper 63 is 69.20%. I'm going to circle those because they're going to go together. Abundance of atoms. Copper 65 has 30.80% abundance of atoms. calculate the relative atomic mass of copper. So I'm going to start off with that formula. So relative atomic mass is mass times percent plus mass times percent. Okay? So my relative atomic mass is going to be, for copper 63, that mass is 63, times, I'm not going to put 69.20 in there, I'm going to put 0.6920. So again, I'm dividing by 100 in order to get that decimal. Gather you up in those beautiful parentheses that my calculator loves so much. Then I'm going to take the mass for the next one, which is 65, times, again, I'm dividing by 100, so 0.3080. And I'm going to let my wonderful, fantastic calculator do all of my work for me. I'm running out of room here on my little table, though. So I'm going to open the parentheses, 63 times 0.6920, close parentheses, plus, open a new set of parentheses, 65 times 0.3080, close parentheses. And remember I'm rounding to 2 decimal places. So this is going to be 63.6, this 6 bumps that 1 up to a 2. So 63.62, and no label, because this makes me really sad, but if you look on your periodic table, there's no labels on their masses either. So I'm going to go look at copper and see if I'm right. So copper is here. 63.55 is what my periodic table says. 63.62 is what my math says. That's close enough that I can feel pretty good about my answer. Okay. Deduce the relative atomic mass of the element from the data. So we talked in the notes about a mass spectrometer. Your mass is on the bottom, so I'm going to underline that mass. And your percent is on the y-axis. In this graph, it's written at the top for you. So our rubidium 85 has a mass of 77% abundant. Let's start off with a formula, shall we? Relative atomic mass is equal to mass times percent plus mass times percent. So the first mass is 85. And my first percent is 77, but I'm not going to put 77 in there. I'm going to put 0.77, so I divide by 100. The other mass I have is an 87, and its percent abundance is 23, so it's going to be 0.23. And again, I'm going to use my beautiful, wonderful calculator that does parentheses for me. By the way, this is $11 at Walmart. It might be worth the investment, just FYI. 85 times 0.77, close parentheses, plus 87 times 0.23, close the parentheses. 85.46, it's to 2 decimals, so I don't have to round. So my relative atomic mass is equal to 85.46. So this is the same process, it's just I pulled my numbers off of a graph instead of pulling my numbers out of a problem. So I'm going to do the back here in a second, which is just slightly more complicated math. Okay? See ya.